about endpoint, and we introduce this definition. And the moment is to measure the tendency of rotation, right? The tendency of rotating about a point. And we introduce cost product to describe the moment. Moment is equal to the position vector cross the force. And so accordingly, moment is a vector, that's for sure. And we need to decide its magnitude. Definitely, we just can use the definition of cost product. It's equal to the magnitude of force times the magnitude of the position vector times sine theta, where the theta is the angle between the force and the position vector. But generally, we don't use this approach to calculate moment. We use the determinant to calculate the moment. That's we calculate the determinant. The first wall is ijk. The second wall is the position vector, xyz components. And then the third wall is the xyz components of force. That's to calculate moment in 3D. It will be much more convenient. And in 2D case, we mean if the forces and the points are coplanar, and this time we can regard moment as a 2D because the moment, the direction according to right-hand rule, the moment is always perpendicular to the panel of the force and the point, right? So we can just describe the moment as negative or positive according to whether it's counterclockwise or clockwise rotation. In 2D case, the moment is calculated by the force times moment arm. Okay, moment arm is actually equal to the moment center, the perpendicular distance from the moment center to the line of action of force F. That's what we have learned yesterday. And today we will continue the study about moment about an axis, because in reality, sometimes when we apply a force, actually there is only a portion of the moment of A is used to turn the socket or to unscrew the pipe. So that means we need to know the projection of the moment about the point A along the axis. Okay. Yesterday, actually, we have introduced how to do this. Definitely, you can do it. You can calculate the moment about an axis in 2D approach, but it's not easy because it's not easy to find out the moment arm. So again, we just prefer the vector analysis. For example, here, we need to find the moment F about axis AA prime. How to find it? Here, we just find a point. It's a point, any point you can choose, okay? It's an arbitrary point you choose on AA price, and then you calculate the moment of force F about point O. That's the position vector cos F. So after we calculate the moment of F about point O, which O is a point on the axis. And then according to what we have learned before, actually the moment about axis AA prime is a projection of the moment of F about point O along AA prime axis, right? And we know how to calculate the projection of a vector on an axis. Is to use the dot product of the unit vector along AA prime dot the vector, right? That's what we have learned before. We introduce the dot product in two ways. dot product can use to find the angle between two vectors. Dot product can use to find the projection of an actor along any axis, along an absolute axis, right? This is what we have introduced the dot product before, right? Here, we use dot product to find the moment about an axis. So first, calculate the moment of f about any point, okay? An actual point, oh, you just choose what you like. Only if it lies on the A prime axis. After we calculate, and then we find the component, we find the projection of this vector. The moment of force F about point O is actually a vector. We find the component of the vector along the axis using the dot product. That's we use the unit vector dot the vector. We can find its projection or its component along A prime. Okay. So definitely we can use the graphical way or algebraic way to calculate the moment, uh, about axis. But generally, we can use the determinant again to calculate the moment about this axis. Here, you say if it's a very specific axis. For example, it's x-axis. So UA, the unit vector of x-axis should be I, right? Should be I. So it will be I, right? And this will be 0, this will be 0, and you can calculate it easily. Or if you want to find the moment about the y-axis, here the unit of y-axis will be j. So this will be 0, this will be j, and this will be 0. Similarly, we can find the moment about z-axis. Use the unit vector of z-axis, k dot the moment of force F about the origin. So you say, if you want to find the moment about, here again, I need to repeat, okay? Maybe I need to repeat. You say here is the equation to calculate the moment about an arbitrary axis. This is UA, unit vector along the axis. If the axis is x-axis of the Cartesian coordinate system, so you say unit vector of x-axis, that should be I, right? So in that case, this would be I. Sorry, I still didn't get the pen. Okay, if you want to find the moment about x-axis, this will be I, this will be 0, this will be 0, right? You can calculate the moment about x-axis easily. And because the moment of F about a point can be any point, can be an actual point, you can choose the origin. The origin can be located, the origin is located on x-axis, y-axis, z-axis, right? Because it's the intersection of x, y, z-axis. Similarly, if you want to find out the moment about y-axis, the unit vector of y-axis will be j. So this time, this will be 0, this will be j, this will be 0. If you want to find the moment about z-axis, you can do the same way. The unit vector along z-axis will be k. So finally, you will find out Finally, if you can find out, if you calculate the moment of f about the ranging, and its x component, y component, z component actually is the moment about x-axis, y-axis, z-axis, right? Okay. So when determining the moment of a force about a specified axis, the axis must be along any line in 3D space. It can be any line. You can use the determinant, or you can use the relation to find the moment of a force about an axis, okay? The triple scalar product results in a scalar quantity, can be negative or positive, a vector quantity, 0, unit vector, and imaginary number. So which answer you choose? Yeah, it's obvious. It's a scalar quantity because the dot product will produce a dot scalar, right? But it can be positive, it can be negative. It depends on the angle between the two forces, right? If the angle between the two forces is smaller than 90 degrees, so it's positive, or larger than 90 degrees, it will be negative, okay? So the answer should be A. The vector operation P cos k dot R equals which one? C, D, B. The answer should be to say in, yes, the answer should be B. Okay, you're right. And here you say P cos K, P cos K, Q, sorry, P cos Q dot R is actually, it's the volume of the cubic, the side is, sorry, it's not cubic hexahedral. Okay, this just like this is P, this is Q, this is R. You see, P cos Q will be the, we mean the magnitude will equal to the area of the rectangular, right? P cos Q, because its magnitude equal to what? Equal to P times Q, the magnitude times sine theta. Right, sine theta. So P cos Q actually will result in the area. Okay, will result in the area. And then dot R, so the new vector dot R, and then should the times some magnitude R times cosine theta. R cosine theta is actually the height of this cubic. So this one actually graphically it's the volume of the cubic, which line is P, Q, R. So the answer should be B. Okay. Or you can use the determinant. You can use the determinant to calculate. Okay. You can use the determinant. Oh, sorry. Am I right? Yeah, no, sorry. We say here P cos because P cos Q. I can explain another way. Sorry, P cos Q will result in a vector, right? Vector dot R will we say they are commutative, right? They are commutative. They're commutative, so this one they can be switched. Okay, the answer should be B. So my explanation, I'm sorry, maybe I'm a little confused here. I'm wrong here. It's not. It's not. So it should be B, but it's not this way. Okay, I forgot. Sorry. Should be because it's dot product and it can and commutative law apply to dot product. So the answer should be B. Okay, sorry. The force F is acting along DC using the triple product to determine the moment of F about BA, which is BA. This is BA. You could use any of the following position vectors except the force F is along DC. Using the triple product to determine the moment of F about the bar BA. You could use any of the following position vector. You can use RBC. You can use RAD. You can use RAC. You can use RDB, or you can use RBD. Which one? Which answer? RBD. Except, what's the difference between RDB and RBD? Can you try? Only one student tell me he or she choose RBD. Any other answers? D. So what's the difference RDB and RBD? The position vector. The position vector starting from D or starting from B, right? You see the moment we can choose an arbitrary point on the axis AB or BA. We can choose an arbitrary point. And then the position vector, right? If you want to calculate the moment F about A, the moment F about B, yeah, it doesn't matter. It's only a point located on AB. That's enough, right? So after we decide, we choose point A. So calculate the moment of F about point A. You can choose a position vector starting from A and ending at D or ending at C. Right. It's your wish. We say it doesn't matter. You can choose any position vector from A to a point. The point is located on the line of action of force F. So if you calculate the moment of F about point A, you can choose the position vector RAD cos F or RAC cos F. But it's important, the starting point is from the moment center A. So RAC, RAD is correct. And then we say you can choose any point or you can choose an arbitrary point on AB. So this time I choose B to calculate the moment F about point B. So moment of F about point B, again, you can choose any point on the line of action of F. You can choose C, you can choose D, but you should be careful. You should be very careful. The starting point is always from the point on the axis B. A force is applied to the tool to open a gas valve. Find the magnitude of the moment of this force about the z-axis of the value. A force is applied to the tool to open a gas valve. You need to find the magnitude of the moment of the force about the z-axis. You need to find about z-axis. So Again, we say about z-axis, we use the unit vector of z-axis, that would be k, right, dot. You can choose a point. You choose a point, any point. After you establish the coordinate, you can choose the origin. You calculate the moment of the force F about the origin O, and then you can find the moment about z-axis, right? So you want to find out the moment F about O, you need to find the position vector, right? The position vector is easy to find out, right? So maybe if you don't want to use this point, maybe you can choose this point. For this point, it's easy to find out the position vector, right? It's really easy to find out the position vector, right? You just find the position vector and then you calculate them. So it's up to you. You can choose an arbitrary point. Okay, so here you can choose an arbitrary point to find out the moment about this point. And then use the unit vector dot the cross product. The unit vector is equal to 1k. Okay. But we need to remind you again that the vector r, the position vector, should be from the point on the z-axis to the line of action of force F. Okay, and because F is already given in Cartesian vector form, so we only need to find the position vector in Cartesian form. The RAB, you see, this is R, this is A, this is B, right? Just as I said, you can calculate the moment F about point O or the origin. It's the same. It will result the same solution. Okay, you can check it. But here we just choose a much simpler position vector RAB. So RAB, according to the figure, we can find the RAB, we find RAB in the Cartesian vector form, and F is already given, and then use the determinant to find it. Okay, so it's not difficult, it's just a mathematics. Okay. So now it's time for you. A force of 81 acts along the edge dB. We need to find the magnitude of the moment of this force about the axis AC. Here, this is the force F. F is only giving its magnitude. We need to determine its Cartesian vector form, and then we need to calculate the force about the axis AC. AC, you say if you can find the unit vector of AC, we can dot them, right? But how about find the moment of F about a point? A point, you can choose A or you can choose C, right? If you choose A, and then the position vector can be AD, so that would be RAD cross F or RCD cross F. It's up to you, okay? So the first thing is to find the Cartesian vector form of force F. Can you try to solve it? I'll give you 2 minutes, okay? So the point is to find the F, find the force F in terms of vector form. How to find the unit vector? I would like to ask one student, invite one student to tell us. Ethan, IHSSIAN is a lady. Are you there? IHSSAN, Ethan. Can you tell me? Are you there? If you don't answer, I will just regard you as absent, okay? Even you, okay. Can you try to tell me the solution, how to find out the force F in terms of vector form? Here, only its magnitude is given. Can you try?
Sure, can find the coordinate of force F.
Find the coordinate of which point? Tell me how to find the force F in terms of vector form. How to find it? How to find out? Anybody just can try other, anyone can just. So how about Wasila? WATHILA, Wasila, are you there? The ID, the last three ID is 126. Are you there?
Yes.
Oh, good. Thank you. So can you tell me how to find out the force F in terms of vector form? Here, only magnitude is given.
Take the coordinates of D.
D, B. Then continue. Continue. Coordinate D, B.
Write it in the Cartesian form.
And then what you will do? You want to find out the position vector RDB, right? Am I right?
Yes. Yes.
Yes, the first step is to find out the position vector RDB. And then after you find out the position vector RDB, we need to divide its magnitude, because what we want the unit vector along DB or along F, right? Are you with me? Here,
Yes.
F is only giving the magnitude, but we know that if we want to find out the moment of the force about the axis AC, that's for sure, because it's a 3D case, it's better to use the vector analysis. So the first step is to find out the vector form of force F. How to find it? dB, the position vector dB, because the coordinate of D, of B are given, right? The coordinates of D or B are given. So it's easy to find out the position vector RDB. And then we divided its magnitude, we find the unit vector of the force F. And then F can be expressed in terms of vector form, right? So let's continue. You see, we find dB, right? It's really important to find dB, okay? After you find dB, what we need to do? We need to find the moment of force F about an arbitrary point along AC. Here we can choose A or we can choose C. It's up to you, right? You can choose A or you can choose C. Okay. So here, if we choose A, that means we want to calculate the moment F about point A. And again, here, if you want to calculate the moment of F about point A, it will be equal to the position vector RAD cross F or RAB cross F. It doesn't matter, right? Because if you want to calculate the moment of F about point A, the position vector should start from the moment center A to an arbitrary point on the line of action of force F. So here we choose B. Why? Why we choose B? We don't choose D. It's up to you. Actually, if you want to choose D, it's okay. But here we choose B, right? Because the position vector RAB is simpler, right? Because it's along y-axis. So IK, the coefficient of IK will equal to 0. Only you got J components, right? That's why we use RAB cos FDB to find out the moment of F about point A. And then, as we said, if you want to find the projection along axis AC, or if we want to find the moment about axis AC, we need to use the dot product. We use the unit vector of AC dot the moment of F about point A. So it will be UAC. How to find the unit vector along AC? Again, the position vector AC divided by its magnitude, right? So I would want to ask somebody to tell me whether I'm right or wrong if I write this way. But first, I would like to OCD. The last 3 digit is 213. Your ID 213. OCD.
Yes, teacher.
Oh, thank you. It's a lady again. Okay. If I say I want to calculate the moment about axis AC, so I will use UAC dot, UAC dot RAD cos FDB is okay. I don't use RAB. I use RAD. The position vector RAD. Is wrong or correct? I mean, here, you see the unit vector of AC, I don't change. But the position vector, instead I use RAB, I use RAD. Is okay? Oh, it's wrong. Yeah, choose. Right or wrong? RAD. I use RAD.
Yes, RAD.
Yeah, sure, definitely. Just as we have talked about it, right? If you want to calculate the moment of F about point A, the position vector only need to start from the moment center A, and it can be an arbitrary point along the force F. It can be B or it can be D. Actually, you can choose any one you like, but only it should not be located on the line of action of force F, right? So RAD is okay. So this time I choose this way. Instead, UAC, I use UCA dot RCD cos FDB. Again, I write down here. I don't use UAC. I use UCA. We know UCA don't equal to UAC, right? Even their magnitude both are equal to 1, but the direction are opposite, right? I use UCA dot RCD, or I use RCB, cos FDB. Am I right? Or this time is totally wrong? Can you tell me? Maybe I can ask another student to tell me. Is Lubingu? Because you don't got your ID here. It's Lubingu, the first name. Lubingu, are you there? Again, if you don't answer me, I will regard you as absent, okay? So you need to reply to me. You need to respond. Okay, thank you.
Yeah, I'm here.
Yeah, thank you very much. Okay, so this time I say I want to calculate the moment about axis AC. Instead, use UAC. I use the unit vector of CA dot bracket RCB cos FDB. Is it okay? Wrong or right? Just need to choose, okay? Right or wrong? Try to
Right.
tell me. It's right. Yes, yes, it's right. Yes, definitely you can use this way. Why? Because we said if you want to calculate the moment about an axis, the first step is to choose one point on an arbitrary point on this axis, right? To calculate the moment of F about this point. So first time I choose A, and then I calculate F about point A. I calculate F about point A, and then I find the axis AC. But here, the axis AC, I mean, here, because axis AC is given, so the direction is given. So here is, I can't use UCA, I still use UAC, okay, UAC. Or the direction will be different. Okay, so the first step, if we want to find out a point, it can be A, it can be C. If I choose C, And then I want to calculate the moment of F about point C. So the moment of F about point C, again, only the position vector start from C and the ending point can be B, can be D. So this one can be RCB or RCD cos F dB. It will be the moment about F. And then start the unit vector. So here should be UAC. Because axis AC, that means the axis is starting from A, ending at C. So it got directions, got sense, sorry, it got sense. So that's why here I use the unit vector of AC. Okay, we can use the unit vector of UCA. Okay, but here it's okay. Or you can use RCD cos FDB. So you got different approach to find out the moment about axis AC. Okay, so I don't want to go to a detail here. We know how to find out. Okay. So for finding the moment of the force F about the x-axis, the position vector in the triple scalar product should be RAC, RBA, RAB, RBC. We want to find the moment of the force F about the x-axis. This is x-axis. This is the force F. So which one is obvious? Somebody say CRAB. Somebody say RBC. First, you want to find out the moment of the force F about the axis. So the position vector should start from one point on the x-axis, right? Should be one point on the x-axis. So only A, right? Only A is x-axis, right? And then the starting point is A, and the ending point should locate on the line of action of force F, so B. So the answer should be C. Okay, the answer should be C. If R is given, is equal to the position vector is given is 1i plus 2j, and F is also given is 10i plus 20j plus 30k Newton. Then the moment of F about the y-axis is, can you calculate? The force F is given, and R, which is R, 1i 2j. This about the R. Which is R? It's sorry, it's not this. Okay, we don't need this figure. Sorry, we don't need this figure. Just calculate is enough. The position vector is given, and then the y-axis, the position vector is given here. We don't need this one. Okay, this figure is wrong here. Okay, we don't need this one. Okay, maybe we take 10 minutes break and then we continue. Okay, I just remove this figure.